So I will start, let's say, in about 5 minutes, because I will allow others to join us, because I usually have over 70 students, or very close to 70, so I really want others to join if they can. In the meantime, you can ask questions. Please feel free to ask any questions that you may have, and I'll try to respond. Let me share my screen. Now you should be seeing my blue screen. Okay. How do you guys hear me?
Very well.
It's good.
Good.
It's good.
Thank you. Now let me then go to chapter 5, and then copy one of the problems from this, and then I'll paste it in the blue screen, and then we start from there. Okay. This is our first problem today. Let me open Excel too, because I will show you guys how to do stuff there as well. Okay. So, do you guys see the blue screen?
Yes.
Yes.
Perfect. So, this problem, clearly we see that they estimated the model. It only has two variables, and clearly one of them is independent variable. In this case, class size. CS stands for the class size. We have how many measures of fit do we have here? Please be involved in class. It's okay to make mistakes. I make mistakes all the time. It's fine. We'll learn from that. So how many measures of fit do we have here?
Is it one Y fit or Y bar?
Which one?
Y, the Y, right? Test score?
No. Let me repeat the question. Maybe you couldn't hear. How many measures of fit do we have here? Oh, what's this? For some reason, my writing pad is not working well. What are the measures of fit that we'll learn in this course? Okay. Let me close this and then reopen. As I said, I'm starting in 5 minutes, so it's okay. So here we have, now it's.
Sorry, we don't see your screen.
I don't see my screen. Here we see two measures of fit. One is R squared, and another one is standard error of the regression, right? Those are the measures of fit. Part A. Do you now see my screen? The blue one.
Yes.
Yes.
First question is construct 95% confidence interval for beta 1. This is the true beta, right? So that's the true population parameter, which we don't know, right? And that's why we want to construct a confidence interval, right? Based on what? Can you tell me? Based on the sample analog or sample estimate of this true population parameter, which is beta 1 hit. Am I clear? So what is the confidence? Do you have a question? So 95% confidence interval for beta 1 is beta 1 hit minus Z critical at 95%, which is that alpha equals 0.05 times sigma hat over beta 1 hat. That's one, and another one is beta 1 hat plus Z critical at 95%, which means that alpha equals 0.05 times sigma hat of beta 1 hat. That is 95% confidence interval for beta 1. So guys, if you have any questions, please stop me anytime. Stop me at any time and I'll try to answer all of your questions. So, do we have all this information? All this information in this problem?
We don't have standard deviation.
We do have this estimated standard deviations of estimated betas. So this 20.4 in the parentheses, that's the estimated standard deviation of estimated beta 0, which is 20.4 is the estimated standard deviation. So, but we are looking for, we want to have the standard deviation, estimate standard deviation of estimated beta 1, which is also given here, which is 2.21. So in the parentheses, we always have, most of the time, we have estimated standard deviations of estimated betas. So, okay, so then beta 1 hat is in this problem minus 5.82 minus 5.82 minus, what is this?
1.96.
1.96. Do you guys agree? Others?
Yeah.
Yeah.
And this sigma hat, beta 1 hat, that's 2.21.
Professor, I'm not getting how you know the standard deviation. Like, is it always given?
No, in this problem it is given.
So how do you know which one is for beta 1 and for beta
I already said. So the numbers in the parentheses next to or below, right below to the estimated coefficients is the estimated standard deviations. So.
Oh, okay. So this one, 20.4 is for beta 0?
Yeah, because 520.4, that's the intercept estimate, right?
Yeah, 520.4 is the beta 0, correct? And
520.4 is the intercept estimate, which is beta 0 hit, not beta 0.
Oh, beta 0 hat, okay. And under it is this standard deviation for
The estimated, so we have to be very careful with the what we say. So these numbers are not true numbers. Those are not population numbers. Those are the sample numbers. So all of the numbers that you see here are estimated. So 520.4, that's the estimated beta 0, which is denoted by beta 0 hat. 20.4, that's the estimated standard deviation of the estimated beta 0, and that's denoted by sigma hat of beta 0 hat, right? And similarly, minus 5.82, that's the estimated slope, or in this case, estimated beta 1, which we denote by beta 1 hat. And here in the parentheses, right below that number is 2.21. That's the estimated standard deviation of estimated beta 1, or denoted by sigma hat of beta 1 hat. Am I clear?
Yes.
Okay, so then the other number will be 5.82 plus 1.96 times 2.21. And then you'll get a number that will be your answer. That's minus 10.5 minus 1.5884. What if I said construct if I wanted to construct 85% confidence interval, what would be Z critical? In this case, alpha would be 0.15, right?
Yes.
Do we know this Z critical when alpha is 0.15?
Is it 1.44? Is it?
Oh, I don't even know. So we have to see, right? I don't remember. So, okay, so I will tell you what that is. So when you have this standard normal distribution, this is Z critical, 0.15. Then what is this area? Can you tell me? And then this will be therefore minus C critical, 0.15. So what will be this area? 0.15, right? Sorry, divided by 2, because it's two-sided test. And here will be 0.15 divided by 2. So, and then what is 0.15 divided by 2? That's, guys, are you with me?
0.075.
0.075.
So then what do we do next? So we are looking for, okay, then it's like, we know that the probability that this capital Z is less than something, some small z, this is what we are looking for, equals 0.075. So we want to see what is our z. Okay. And we can go to the table. Do you see my screen? The table.
Yes.
And we are looking for the closest probability, which is closest to 0.075. 0.073, right? 74.
1.4.
think that's the closest from this table. That's the closest we can get. Am I clear? Oh, so who said minus 1.44? That's correct. That's the Z critical, right? Because you see that that probability 0.0749 corresponds to this minus 1.4, and then on the up you have 4. So minus 1.44. So minus Z critical is minus 1.446, and Z critical will be, so let me share this screen again. Why do I have, okay. So minus Z critical at 0.15 is minus 1.44 from table 1, but then this means that Z critical at 0.15 will be 1.44. So then if I wanted 85% confidence interval, then how would you calculate that? Everything would be the same, but instead 1.96, it would take what? 1.44. And here as well. So guys, am I clear? Please let me know, and others too, because you may see problems like this in the exam. So
Yes, sir.
yes.
So so the alpha in the second example is 0.15, right?
Yes, because why? So no. Alpha is 0.15 divided by 2.
Okay, but
where is it? So maybe I made 0.15 divided by 2. This is like 0.15 divided by 2. If that, I think that's good.
so
Sorry, it's not. Sorry. It's 0.15. Alpha is 0.15.
yeah, because for the other example you didn't divide 0.05 by 2, so I was just confused.
No, I did. So this 1.96, guys, it is a conventional number. So it's like when I say 1.96, in that case alpha is 0.05, but that means that here you have 0.05 divided by 2, and on that side you have 0.05 divided by 2.
So wouldn't you look up?
This is alpha over 2. This is alpha over 2, guys. Alpha is 0.05.
So wouldn't you look up in the table 0.0025 and not
exactly?
0.05?
So you would be looking for, so it would be here it would be probabilities that Z is less than small z, and you're looking for this small z, and this is equal to 0.025. And then you will realize that this z is 1.96 with minus. Am I clear?
I'm just not getting how, like,
okay. Let me re-explain.
So
when you have alpha equals 0.05, right? That means that here in the standard normal density, right? On this side, you have, this is your z at 0.0, let me call it critical, at 0.05. But when I say 0.05, it means that I have 0.05 divided by 2. And the area here is minus z critical at 0.05. That means that this area is 0.05 divided by 2 because the sum of these two is 0.5. And that's equal to 0.05. So I'm looking for this z and I'm looking for this c. And so what are those z's? That's probability that is capital Z is less than small z. That is what you are looking for is 0.025. Now you will go to the table. Let's go to the table. So we want to see the number which is the closest to the 0.05, right? Now you should be seeing my table, and 0.025 will be is exactly here. Do you guys see?
Yeah, I get it.
What is the z critical value that corresponds to this number? It's minus 1.996, right?
Right. So the z critical for 0.05 is not 1.6. It's the z critical for 0.25. That's 1.96.
Yes, when alpha, but you need to be very careful. So whoever you are, very, very good, but it is alpha 0.05 when you have two-sided test.
Isn't it when you have a one-sided test, the alpha is 0.05, and then a two-sided test is 0.025?
Yeah, so when you have two-sided test, alpha 0.05 is distributed into two tails equally, right? So I don't want to confuse you guys, but you can construct a one-sided confidence interval where your alpha would be 0.05 and would be only in one of your tails, right? If it was one-sided, it would not be divided by two, and then you would get a difference. So you are not looking for this. In this case, you would be looking for this probability, for this z.
Professor,
But for now, we are not. So this would be when you are constructing one-sided confidence interval.
Professor,
Yes.
wouldn't it be 1.98 based on table 2?
Table 1.
No, because when I did it on the homework and I did 1.96, it was wrong because of the sample size.
Yeah, but yes, true. But in this case, do we have, what is our sample size?
100. So it should be less. I mean, it should be.
So I agree, whoever you are. The thing is, let's assume that sample is large enough. Let's now use table 1, right? So I will talk about when we use table 2. You are right, because when do we use table 2? Can you tell me? When the sample size is not large enough, and large enough means that sample should be greater than 120.
Yeah.
Right? But for now, let's assume that the sample is large enough. Let's assume that, okay? Okay, so next question. Calculate p-value for the two-sided test that h null beta 1 is equal to 0. Okay, so this is p. We have this test 0, h null beta 1 is 0, and h1 or h alternative beta 1 is not 0, right? So what is your next step? That next step is to calculate test statistic, right? That will be, I explained this before, that will be beta 1 hat minus the hypothesized value, which is 0, divided by sigma hat of beta 1 hat. Do we have all these numbers? Yes, we do, because we know that beta 1 hat is this minus 5.82, and this estimated standard deviation sigma hat of beta 1 hat is 2.21. So therefore, we can calculate this. And that's, let me see, that's minus 5.82 divided by 2.21, and that's approximately minus 2.6335. And then, okay, so this is the test statistic. So then what is the next step? So you can, but the thing is, we here need to calculate the p-value, right? So what would be with the p-value, guys? So remember, what's this? So this is a standard normal density. Usually standard normal density is not looking like that. Standard normal density will be, unfortunately, I'm very bad in drawing. I'm actually very good in drawing. I was quite good in drawing. So this is minus 2.6335, right? And the p-value is what? Can you tell me?
Is it the z critical of negative 2.6335?
And can you repeat, please, because I could not hear.
Is it the z critical of
No, it is not z critical. P-value is the probability.
It's a 2 multiply now to test statistic.
No. P-value, so is what? For two-sided, this is your test statistic, right? You need to multiply that test statistic by 2. Here you will have 2.60, not 2 by minus 1, and therefore you'll have 2.6335, and the p-value is the area below this test statistic and above minus 1 times that test statistic. So this is area 1 and this is area 2. So the p-value is the sum of these two areas. But these areas are equal, right? And therefore the p-value is 2 times area 1. But what is area 1? Can you, guys, do you see what I am writing?
Yes.
So, but can you tell me what is area 1? That's the probabilities that is capital Z is less than what?
Small kg.
Negative 2.6.
335. So we need to calculate this area, right? So that probability. Okay, so you can do this in Excel. We have already done it, but you can also see this in the table. Z here is Z is minus 263 small z. 35, but in that table you don't have that many decimals, so you have to round it up to decimals, and then you have 2.63. But in that table, that is decomposed into 2 parts, minus 2.6 and the 3, and then you are ready to go to the table. Well, remember, minus 2.6 and the 3, and we are looking for the probability that corresponds to that. And let me share the table again. Minus 2.6 is here. You guys see that, right? And then 3 is here, so that's the probability, right? 0.0043. Guys, am I clear?
Yeah.
So then we have to, then it will be 2 times 0.0043, and that's 6800 and 0. So p-value is, we calculated this.
Sorry, we still see your the distribution table.
Okay, thank you, guys. So what I said here is that, so we have 2 times 0.0043, which is 0.0086, and that's our p-value, guys. And then we have alphas, right? 1. What is alpha at 5% significance level? They're saying 1 and 5%. At 5% significance, when alpha equals 5, 0.05, sorry, what is the critical value when alpha is 5% or 0.05? Since Z critical, we know equals what?
1.96.
That's for two-sided, remember. And then it's okay, good. So, but we're not really interested in that. So that's alpha. So p-value which is 0.0086, and then we have alpha, which equals 0.05, and we know that this is greater clearly, right? So 0.05 is greater than that. So what do you conclude?
Reject the null hypothesis.
Good. But what at 5%, right?
Professor, I have a question. So to find probability of z less than -2.63, how would you do that on Excel?
Let me do it, right? So, but first let's finish this. Second, but what is, and then we have alpha, which is 0.01, right? That's 1% significance. By the way, do you remember the critical? We don't really need it, but do you remember the critical for this?
Is it 2 yeah, something like that.
But it's for two-sided test, right? For one-sided, it will be different. Remember, just this is like an extra thing, we don't really need it. And then again, you have p-value. What did I write? Which is 0.0083, and then you have alpha, which is 0.01, and then and then again you reject. And then the question that you guys asked was, okay, then we have z, which is equal to -2.6335, and how do we do this in Excel? So do you know see the Excel? Excels?
Yes.
Okay, then, so we have this -2.6336, right? 35.
5.
And then we are interested, what's the p-value that corresponds to this test statistic, which is in this case small c, right? So okay, good. So then equals, as I remember, it is norm list. Norm list, our x is -2.6335. Mean is it is standardized, so we have mean which is equal to 0, standard deviation is 1. We are looking for the cumulative in this case, and then we will either write true, or true is also denoted by 1, and that's the probability. But is that p-value? If it would be p-value, if it was just a one-sided test, but it's not one-sided test. The p-value then will be so equals 2 times this, and that's the p-value that we also very close number will also obtain from the table. Guys, are you with me?
Yep.
Yep.
So, you know, we explained quite a few stuff today. I'm not explained, but we reviewed quite a few stuff today. So, do you guys have any questions?
Professor, how do you know it's a two-sided test?
Very good. So you know that from the hypothesis. What is your hypothesis? The hypothesis was is that in the alternative you have the beta 1 is not equal to 0, and that means that you have two-sided test. If you had, let's say, beta 1 less than 0, would be left or one-sided test, left-sided test in that case. Or if beta 1 greater than 0, then it would be again one-sided and right-sided test. Am I clear?
So is it because we have an alternative hypothesis that we do a two-sided test?
Yes. If whether the test is one-sided or two-sided is determined from the alternative hypothesis. Now, see. Now we are testing a different hypothesis. In this case, we are testing that beta 1 is equal to minus 5.6. And we are not required to do any additional calculations. And why? Because we don't really need it, right? So let me copy this again. Now, part C. Now we are testing whether H null where beta 1 is equal to 5 minus 5.6 and H1 or H alternative is that beta 1 is not equal to minus 5.6. Without doing any additional calculations, determine whether minus 5.6 is contained in the 95% confidence interval. So to answer this very simple question, guys, you really need to understand everything in details. So for part B, guys, are you with me?
Yep.
Yes.
Because I will answer a few questions that will also check whether we understand stuff. It's okay if you don't fully, because we will understand eventually. So let me ask you. Okay, we know that we rejected the hypothesis in part B, right? We just did it. We did it a few minutes ago. Does that mean that 0, which is the hypothesized value, is in the 95% confidence interval?
Can you repeat that, please?
So we rejected the hypothesis in part B at 5% significance level, right?
Yep.
Does that mean that the hypothesized value of beta 1, which is 0, is contained in the 95% confidence interval?
No.
That's absolutely right. But why?
Because we rejected the no, which means that the 0 was not between the interval we had in the count.
Very good. So do you guys understand it? Others?
No.
Okay. Let me ask a additional question, and then I will go back. So to the one who said that it's not in the hypothesized value 0 is not contained in the interval, in the 95% confidence interval, then can you tell me whether minus 5.6 will be in that interval?
No.
Why?
Because it's a smaller value than 0, and the p-value for 0 was already very small compared to the z critical, I think we had.
Absolutely, that's right. So that's why you don't really need to do any calculations in part C, right? But let me now explain. Okay, let me do part D, and then I'll go back to part C, okay? Because part D is very simple. Part D is about 99% confidence interval for beta 0, right? And it's really easy, right? Because you know what's beta 0 hat, right? Above. That will be beta 0 hat minus z critical at 1% times beta 0, sorry, what did I write? So sigma hat beta 0 hat, and then you have beta 0 hat plus z critical 0.01 times sigma hat beta 0 hat, and that's the 99% confidence interval. What's z critical at 0.01? two-sided?
2.58.
Same thing here, right?
Yep.
And we know that, and we know this, right? Because it is given here. That's doesn't really write on this, but we know that, right? So it will be 520.4. So one of you guys, I think it was, okay, asked me how to do this in Excel, and that's, I mean, how do I do confidence? There's no like built-in function for confidence intervals in Excel, but you can do this, right? So how do I do this in Excel? I just calculate this, right? And I calculate that in Excel, and that will give me confidence interval. Am I clear?
Yes.
Okay, now let me
Professor.
Yeah.
Can you go back for a second, please?
Sure.
How did you get the number 2.58, please?
What is that? That's if you look at this standard normal density, we are looking for Z, which we call critical, and alpha is 0.01. Because the test is two-sided, here you have the area, here is 0 everywhere, is 0.01 divided by 2. But because the test is two-sided, then you have here minus C critical, again at 0.01. But when I say 0.01, it means that the area here is, this is alpha, guys. This is alpha. It's not alpha over 2. This is alpha. You can also, if you say alpha over 2, people don't really do it. They just say alpha two-sided, and they imply it's alpha, and that will be 0.01 divided by 2, right? But what is this? That's 0.005, right? Do you guys agree with me? And then you calculate Z minus Z critical. This Z either based on table or in Excel. So so you are really looking at the probability that this capital Z is less than your small z, and this is the Z that you are looking for, and you know that is 0.005. So then, okay, then you are looking for this probability in table 1, 0.05, 0.005. And then you see, okay, and then you're looking for these probabilities here, and you see that the closest is this one. Do you agree with me? The closest to 0.005 is that, or that. But people take 0.0049 as closest to 0.005. Am I clear?
Yes.
And then Z that corresponds to that number is minus 2.58. Minus 2.58. Am I clear?
Professor?
Yes.
Is there any time like where it's positive instead of minus 2.58?
Let me now finish. So minus Z critical at 0.0 and alpha is 0.01 is minus 2.58, and then this implies that Z critical at alpha equals 0.01 will be clearly 2.58, right? So here you have minus 2.58, and here you have 2.58. This minus 2.58. So, and that's what you see here, minus 2.58 plus 2.58. Did I answer your question?
Yeah, thank you.
Now let me go back to so this is Z critical when alpha equals 0.05. So that means that this area is alpha over 2, and that's 0.05 divided by 2. This is minus Z critical for alpha 0.05, but this area we know is alpha over 2, therefore that will be Z 0.05 divided by 2. We know this Z critical is equal to minus 1.96, and minus Z critical will be minus 1.96. Guys, up until now, am I clear?
Yes.
Minus 2, do you remember that our T stat was what? It was minus 2.6335 above. Guys, you can look at. What is it? T stat, guys. It was minus 2. Do you see the blue screen?
Yeah.
Good. So test statistic was minus 2.63, right? Okay, and that falls. Maybe this will be better. What do we call? Oh, that's definitely not perfect. Maybe this one. Okay, what do we call these regions?
Rejection.
And also this is also rejection region, right? Am I clear? Minus 2.63 falls here, right? Because here is minus 1.96. Am I clear?
Yes.
And that's why you reject it. What do we call this interval?
Acceptance.
Confidence interval,
And you rejected the hypothesis, right? And okay, do you remember what was the hypothesized value? It was a test. Beta 1 is 0. So this is the hypothesized value, right? So let me remind you guys. Okay, this is a test. The hypothesized value is 0. And did I calculate the confidence interval? I'm not sure. I'm looking for it for this test. I think I gave you numbers. I'm just interested. But 0 should not be in the confidence interval. That's what I'm trying to show you guys. This one, right? This one, guys.
Yep.
So that was the 95% confidence interval for beta 1, right? Am I clear?
Yes.
Yes.
Is the hypothesized value 0 inside this interval?
Yeah.
No, it's not.
No.
How is it?
Oh no.
That's,
Yeah.
that's why you rejected
Right.
the H now. I just wanted to show you that. So let me now remind you something. So when do you reject the hypothesis? We already said it before, but let me remind you guys. When? Because you will find this useful in the exam too. What is the first method? When the absolute value of the test statistic is greater than what? The critical value, right? You reject H now. What is the second method? Can you tell?
And the p-value is smaller than
Less than significance level, right?
Yep.
Which is usually alpha, right? Reject H now. And then there's another one that you probably did not remember well, but that's okay. That's why I'm here. And then what if the hypothesized value falls outside the confidence interval, and reject or fail to reject H now.
Reject.
Yes. So the hypothesized value was 0. I showed you guys above already that it is not in the confidence interval, right? 95 was not, right? Because both of them were minus, so how can 0 be inside, right? So, and that's why we rejected. Okay. And that's, I think, all for this problem. 5.1 is a pretty easy problem, but we still need to understand some very critical aspects of that problem, and I hope we did it. You will get this recording, guys, and please, if there is any question, please listen to it. Also, you can always email me. So if you let me, I will do the next problem. Is it okay if I go and do the next problem?
Yep.
Okay. So then let me copy next problem, which is 5.2. Okay, that's the next problem. You see my blue screen, right?
Yes.
Yes.
Okay. Let's do part A of this problem. Sorry. Okay, so for some reason, I don't know why it's not working. Okay. Now let me do part A of this problem. We again see the estimated model. And the first question, part A, is what is the estimated gender gap? So here, male is a dummy variable that takes value 1 if individual I is male and takes value 0 if individual I is female. Okay. What is wage head? Head for males, can you tell me? Times 1, right?
Mm-hmm.
And that will be 4, 6, right? Can you tell me, this is like, I have to indicate here, this is for males. Wage head for females will be 12.52 plus 2.12 times 0, and that's 12.52. Then the gap between wages, which I denote by delta. Okay, so I can also do like gap, wage gap, or estimated wage gap is better. Gap head, or will be, that's the difference between the two, that's 14.64 minus 12.52, that's 2.12. And that's the, if you look at it, it's exactly the slope estimate, that's what it should be. And that's 2.12. Let's do now part B of this. Is the estimated gender gap significantly different from 0? What is the test hypothesis here? Can you tell me? Guys, are you with me? What is H now?
H now, would it be the gender gap is equal to 0?
But I said that gender gap is
Not equal. Wouldn't it be not equal to?
no, hypothesis will be that beta 1 is equal to 0, and then the alternative will be that beta 1 is not 0. Why beta 1? Because beta 1 measures what? Am I clear?
Yes.
And then clearly the test statistic will be, for some reason I don't have around 70 students, I don't know why. Beta 1 hat divided by sigma hat of beta 1 hat. That's, if you look at the 2.12 divided by 0.36, and x equal to 0.89. And then if you can compare these to different critical values. What is the critical for two-sided test when alpha is equal to 1%? And then we know that 5.849 is greater than 2.58, so that means reject H null at 1% significance level, but that automatically means that you are also rejecting the hypothesis at 5 and 10% significance. Levels too. If you guys have any questions, stop me anytime and I'll answer your questions. Then the next question is construct 95% confidence interval for the gap. So that's like construct 95% confidence interval for beta 1, which you guys already know how to do. The next question is construct so you know how to do it. Try it yourself. Similar to what we did before. Part D. In the sample, what's the wage, the mean wage of women and men in the sample? Okay, so let me rewrite that wage hat equals 12.52 plus 2.12 times. All right, so and then this is like very similar to part A. And so it's like it asks us to first to calculate the mean wage for women. That will be the same as I did before. That will be, sorry, that will be 12.58 plus 2.12 times 0, that's 12.58, and then mean wage for males is 12.58 plus 2.12 times minus, what's that? 52, sorry, it's 52. That will be 4, 6, 14. And the last part of this question is more interesting. They want us to rewrite this model so that for as the independent variable instead of male, we have female. And that's easy to do because, okay, so we have wage at equals 12.52 plus 2.12 times male. And we know that male equals 1 minus female because we defined male as 1 if a person, individual I, is male, and 0 if individual I is female, and we define female, another dummy variable, as 1 if a person I is female, and 0 if person I is male. So these two definitions imply that male variable, the variable male is 1 minus the variable female. So here you can substitute 1 minus female then. So, and then you will get 12.52 plus 2.12 times 1 minus female, and then you just rearrange terms. So we'll get 12.52 plus 2.12 minus 2.12 times female. So then means wage head equals, and then you add these two, 4, 6, 14.64 minus 2.12 times female. So we rewrote the above regression where we had male dummy variable male as the independent variable into another regression, which is the same, but in this case, same regression, but in this case, as the independent variable, we have female instead of male. Okay, and that's all. I think this problem, let me see. Okay, so then we know the regression estimates are, in this case, the beta 0 hat will be 14.64. That's different from the other regression. And the beta 1 hat is minus 2.12. And you can do all kinds of hypothesis tests based on test statistic, based on confidence interval, p-value. You can do all of those. Now let me do the next problem. Oh, maybe let me see. Maybe we can stop here. But what is the next problem?
Sir, I have a question.
Sure.
How did you get the 2.12 again? Why is it twice? And
Because this is like 2.12 times 1 minus 2.12 times female.
okay. Got it. Thank you.
So guys, let me stop here. And I will see you on Monday. Next class is on Monday, and I hope that I will see you all. We will do more exercises. The assignments for the homeworks for these 2 chapters, 4 and 5, are already assigned. If you can start working on that. I already postponed the due dates of all the assignments. I think until November 1st. Remember that we have our midterm on November 2nd. Please try to prepare for the exam because there will be a good chance to improve if you're not happy with the first exam. And again, if you have any questions, you can always contact me. Feel free to reach out. Okay, guys, let me finish today's class, and I will see you on Monday. Have a nice weekend.
Thank you, Professor. See you on Monday.
Thank you.
Thank you. Have a great weekend.
Thank you.
Thank you.
Professor, I have a question.
Sure.
Are you going to be putting on Blackboard the the questions that you're going over today, right? Like the answers that go with them. Will you be posting them just like you did for exam number 1?
I think they should be already there, but
Okay,
I will
perfect.
double check.
Sounds good. Thank you.